Okay, so maximum flow problem. We will start from maximum flow problem.
Hmm.
So maximum flow problem, basically a network flow problem, means
Hmm.
if there is a
Something
network.
like Huffman only.
Sorry.
Something how the Huffman was related to network.
Huffman was related to network in that way. Through a network, if you want to send a data, okay,
How we
then
can reduce the code and send
yeah,
it faster.
yeah. So that
How to increase the efficiency of communication.
compress.
Hmm.
Huffman coding is related to compress the data so that less
Hmm.
number of bits you need to send. Okay.
Hmm.
Mm, one. Acha, in Huffman coding,
Hmm.
I told you about the variable length coding, na?
Yes, variable
Fixed,
size you have given.
fixed length coding. You know? Do you know fixed length coding?
Fixed length coding also we did it.
We did. Okay, no problem.
Ah, we
So
did.
in fixed length coding,
Hmm.
you should have. Uh, you may have some short questions from there. So to
Hmm.
find
Hmm.
what is the code. Okay.
Okay.
Okay. Now let's start this one. This is iterative maximum flow problem, and the important algorithm here is your Ford fulkerson method. Okay. Now network problem. What is network problem? Network problem is basically, okay. Let me copy the heading here. Algorithm Ford fulkerson. This is an important algorithm. Computational purpose. They
Hmm.
may give this one also. Means you have to compute the value for maximum flow throughout a network. Okay. Now for that purpose, I want to copy the graph given by them here. Where is the graph? Okay.
शायद
There,
नहीं किया है ये.
no, there is no graph. Okay, maybe it is there in the PPT, na?
हाँ class पे.
So 09. So it is 9. There must be a graph. Otherwise, how the competition will be described by them. So unit 4. It will be on unit 9. Horse pull. This is unit 9. Lots of thing she did. Unit 9, where it is? Unit 9. See, Ford Fulkerson algorithm. Okay, I hope there will be a graph at least one. Yeah, these are the graph. Very small. This one. Yeah, we can take this one. Okay. Hello.
हाँ I'm there.
Okay. So find maximum flow. This is the graph. I think this is the graph, na? So
Hmm. That is the graph.
we can copy the graph and paste it somewhere. Where is the pinned partition? Sometimes it is very irritating for me to handle these Windows 11 and 10.
Yeah, they have done so many these things like unwanted additions.
So this is a network, okay?
Yeah.
This is a network. Now
Mm.
we have to find means how they will give you the question. They will give you the question in that way. Okay, find the maximum flow of this network. Okay, find the maximum flow of this network. Now this is a network of, you may think about a network of say pipeline, means water flow or gas or oil flow in a factory. Okay, these are the pipelines, these arrow are the pipelines, and these are different nodes, a b c d, these are different nodes. Okay.
Okay.
So the purpose is to send, say, flow of oil, okay, or chemical, anything, you can take anything, flowing
Okay.
throughout a uh,
Uh,
through the pipelines over a factory. If you have any day, if you visit the Jamshedpur, the steel city, Jamshedpur, the
I
Tata
know,
Steel
but not
factory. I
not.
I visited multiple times over there. I was engaged in a very big project in Tata Steel along with TCS. So if you visit Jamshedpur Tata Steel factory, you will find it's a complete whole city, means inside their factory. It is a factory, but it is a campus that is everywhere you will find the pipelines over your head,
Mm-hmm.
beside you. You have to travel from one point to another inside that factory through car. You cannot, and this is, there is no walking distance, it's a huge area. Okay, so you have to travel through the car. Okay, now as soon as you enter from the main gate inside the campus, you will find lots of pipelines over your head, along with you, it is moving. So
Mm-hmm.
through those pipelines, gases, oils and chemicals have been flowing all around the factory. Okay, and it is over the factory, more or less over 3 to 4 5 kilometer, maybe more than that area.
Oh. Oh.
Okay, at a stretch, maybe more than that. I'm just uh,
Okay.
giving my assumption, only that part where I went. I worked in a project, I have the videos. It was mm, 2013, 13 14, 2 years.
Oh.
So I was working in a hot mill section, means where the steel rolls have been
Mm-hmm.
rolled in a bobbin.
Okay.
Okay, anyway, so there is a very huge network of pipelines. Through the
Mm-hmm.
pipelines, the chemicals and other elements were flowing. Okay, so like this, these are different nodes. Okay, so among
Mm-hmm.
these nodes there are two special node. Okay,
Uh,
those two special node are this one, this is called source.
mm.
One is called source, so this is your source, s is your source. So this is your source. Okay,
Mm-hmm.
and this is your sink, this is our sink, means the purpose is to send the flow from source to sink. Okay,
Think.
t is the sink. So these are the two special points in the network, and the total picture, this picture is called flow network. You can identify this is
Mm-hmm.
called a flow network. So
Mm-hmm.
the purpose of this algorithm is to find the maximum flow that can passes through the network from source to sink. Okay,
Okay.
what is the purpose? The purpose is to
Maximize
find
the
the
flow.
maximum flow from source to sink through the network. Okay, so to find that, to understand that algorithm, we will calculate the maximum flow according to Ford Fulkerson algorithm. Okay, but for that you need
Hmm.
to know a few terminologies. First,
Hmm.
you know what is source and what is sink. Okay,
Hmm.
then you have to know something called capacity. Okay,
Okay.
see, A is a node and B is another node. Okay,
Hmm.
so the maximum capacity that a flow means maximum capacity of
From A
element
to B.
that can be flow from A to B is 5. So 5 is the
Okay.
capacity. Okay, so 5 is the,
Is it 0 to 5 or 5?
no, only 5, only 5. So this is your
Why it is
capacity.
given 0 out of 5?
0 0 I am telling you na. 5 is the capacity. Okay, so 5 is the
Okay.
capacity of this edge, or you can say this path. 5
Hmm.
is the capacity of this path from A to B.
Hmm.
Means
Hmm.
maximum 5 unit of item you can send through A to B.
Hmm.
And this is the flow. This is called flow.
Okay. 0 is called flow.
0 is your flow. Means, so
Hmm.
by means of 0 by 5, it's not by, 0 out of 5 means nothing is been flowing from A to B till now.
Hmm.
If you find 2 and 5, that means uh, among 5 out of 5,
Oh,
2 items are
two
been
with
flowing from A to
two
B.
items are flowing. Okay.
Okay, so this is your capacity and this is your flow. Okay,
Hmm.
now there is a term called residual capacity. Now what is
Hmm.
residual capacity? Residual capacity is your maximum capacity minus flow, total flow. So what will be the residual capacity of this edge? What will be the residual capacity of this edge? 5 minus 0.
With
So it is
3
0.
by 5. 3 with 3.
No, not 3. This one, this one. Okay. So
That is 5.
residual capacity is maximum capacity minus flow. Think about this. If this is the maximum capacity, na, and this is the
Hmm.
flow. So 5 minus 2,
3.
3. So 3 becomes the residual capacity of this edge. Of this edge. Okay.
Hmm.
So residual capacity is the capacity, means the remaining capacity of the edge, remaining capacity of the path.
Hmm.
If it is 2 by 5, that means you have already transferred 2 items. Na? So how
Hmm.
many items are left? 3 items.
3
So
items are
3
left.
becomes the residual capacity. So these are some terminologies used in this
Hmm.
algorithm. So you understand residual capacity?
Yes, I got it.
Okay. This graph is also known as residual graph. Okay. Residual
Okay.
graph. Now, what is a residual graph? Residual graph is such a graph which contains the edges, residual edges. Okay.
Hmm.
So, since all the edges are residual edges, means we can have the remaining capacity for all the edges. So, it is a residual graph. Okay. So,
Hmm.
there may be a short question like that. I remember that in CA3, there is a question maybe a Ford Fulkerson method use what kind of graph? Residual graph, dash
Yes,
graph, dash
yes.
graph, dash graph, like that.
Yes, yes. It was there.
Hmm. Okay, so you understand the
Yeah, I got it.
terminologies. Okay, I am going to use those terminologies in the description. Okay,
Hmm.
so the next one is your flow. Flow. Okay, flow. I told you capacity, maximum flow, residual graph. Next, path, augmenting path. What is augmenting path? Augmenting path is any path from source to sink.
Hmm.
Okay, augmenting path is any path from source to sink. Okay,
Okay.
with flow that is greater than 0, you can say. Means initially
Hmm.
it will be 0. Okay,
Hmm.
but when we compute, these zeros will be changed. Huh?
Yes.
So augmenting path is any path from source to sink with value greater than 0. You can say like that.
Mm.
Okay. Okay. So these are all about your terminology. You got it?
Mm.
Okay.
Okay.
So what are the terminologies we need to know? First is your source,
Source,
then sink,
sink,
then what is the capacity,
capacity,
what is the
then flow,
flow, what is called by
then
flow, then what is augmenting path,
real capacity.
then residual capacity. Okay, one more thing remains, that is bottleneck capacity. Now what is
Mm-hmm.
bottleneck capacity? You know the term bottleneck. Okay,
Mm.
suppose this is a augmenting path, right?
Mm.
Obviously this is a augmenting path. What
Mm.
is the minimum capacity along this path?
Mm-hmm.
What is the minimum capacity? Tell me, along this path.
Minimum is
The capacity of
five,
this edge is 7. The capacity of this edge is
5,
5.
12,
Capacity of this
and
edge
8.
is 8. So 5 is the bottleneck
20.
capacity. No, 5.
Okay.
Bottleneck capacity is for a path from source to sink. Okay. So
Mm.
bottleneck capacity is the minimum capacity for a augmenting path, for an augmenting path.
Okay, okay.
Okay.
Got it now.
So the
Mm.
minimum capacity that you can pass from source to sink along this path, that is bottleneck capacity.
Mm.
The minimum capacity, minimum, how much item you can pass from source
Okay.
to sink through this path, that is 5. So that is your bottleneck capacity.
Okay.
Got it?
Mm.
Tell me,
Okay.
is it okay?
Yeah, yeah. We can
Okay.
continue.
Now how can we proceed? Okay, we can proceed, means we have to consider all the augmenting paths that are possible, augmenting path for the graph. Okay, and
Mm.
change the residual capacity. Let's see.
Okay.
So I'm copying this one again, copy it, the first one. Okay, let me draw a table, means I will, I can draw a table like that. Say here you will find the augmenting path, and here you will find the bottleneck capacity, right?
Okay.
Here you have to find the bottleneck capacity.
It is for all the edges, no?
Not for all the edges. I
Only
am
from
telling
source
you
to
it
sink.
is for the augmenting path. Okay.
Path
We have
means
to
source to sink.
find the augmenting path, then we have to find the bottleneck capacity of that augmenting path, and we proceed. See, these are very simple algorithm. You will find it
Hmm.
very easy and interesting too. Okay, if you
Hmm.
understand, means if I am able to make you understand. Okay, so let's see.
Okay. Understood.
Okay, so now consider fast augmenting path. Anyway, you can take any augmenting path. Okay, so what are the augmenting path here?
Yes, A, B,
Say
T.
this is augmenting path and this one is an augmenting path. Okay, and this one is an augmenting path, right?
Yes.
Because it is a directed graph. See here, this one and this one is an augmenting path, so there are many augmenting paths. So we
Hmm.
will start arbitrarily by choosing any augmenting path. Okay.
Okay.
Uh, so by choosing any augmenting path, we will see that after 2, 3, or 4 choices, maybe we are not able to take any augmenting path more. That time
Mm-hmm.
we are finished. Means the solution has already been
And
given.
solution, we would have arrived at solution.
So you do not have to consider all the augmenting path. Okay.
Okay.
So let's see. Start any augmenting path. You tell me which augmenting path should I start.
ABT
So we start with S to A to B to
to
T.
T.
Okay. Just try to understand my handwriting because I am using
Yes, no, no, no,
mouse.
no. It is very clear.
Okay.
Hmm.
So if this is the augmenting path we are considering, then what will be the bottleneck capacity of this path?
5.
The bottleneck capacity of this path will be 5, right?
Hmm. Now
Okay.
taking the next argument path. S to D, D to C, C to T.
So just a minute, Shashiji.
Hmm.
So this is your bottleneck capacity, right?
Hmm.
Now, what you have to do? You have to give this flow in this path. Okay. So if
Hmm.
you give this flow in this path, then what will happen? You will you have to uh, alter the flow.
Hmm.
You have to
Hmm.
alter the flow component in this path. Okay.
Hmm.
So how can you give it? So just give 5 to it, right?
Hmm.
Give 5 to it. Give 5 to it. So you have assigned the bottleneck capacity along the path, right?
Okay.
Okay. Now here I am writing the output max flow, right?
Hmm.
Max flow. So how much you give along the path?
5.
5 plus. Okay. So if you give flow 5 to all the edges, then calculate the residual capacity. What will be the residual capacity?
2 over there.
It is 2. Okay. It
There
is
0.
0 and it is
3.
3. Now see, this becomes 0. What that mean? This signify that no more flow is possible from A to B
Hmm.
because the capacity has been
Reach to.
consumed. Okay, all the full capacity has been used for this path.
Hmm.
So you cannot move any flow from A to B. Okay,
Hmm.
okay, fine. So we have considered this path is to
Hmm.
A to B to T. Okay, now we
Hmm.
have to consider another augmenting path which is not through A to B.
Hmm.
Means we have to consider another augmenting path which do not include A to B, right? Because
Hmm.
it has flow
Is
equal to
become
0.
0.
Okay. Now, while we are considering the next part, we will consider the residual capacity only. We will not consider the original capacity, right?
Hmm.
So we can better copy this image and put another. In exam, you also have to do in that way, only in
Hmm.
that
Hmm.
way. Okay. Now tell me which augmenting part you will select. You tell me.
S D C T.
SDCT. Okay.
Hmm.
S to D to C to T. So what will be the bottleneck capacity of this path?
This path will be 2.
2 is the minimum.
Hmm.
Is it 5?
It is 2 only.
No, this one is what?
Ah, that is 5.
Yes, that is 5. Okay. So the bottleneck capacity is 2.
Capacity is 2. Hmm.
Okay. If the bottleneck capacity is 2, then what you have to do? Tell me.
You have to change this all by altering the flow.
Yeah. So assign
That will be
2,
residual will be 2.
2, and
It
this
becomes
will
again
also be 2.
0. This
Okay.
will
So
be
when
2
you
means.
you have assigned 2, then first
Hmm.
what you do, you put this to here, max flow. Okay.
Hmm.
After that, you you calculate the residual capacity. So what will be the residual capacity of this node? This will be
Which one? That will be 2,
2. This will be your 0.
0,
So
and that
if
will
this
be
is
3.
0, you block this path. We block this
Hmm.
edge. So it will be your
Uh,
5 minus
think
2 is 3. Na?
3. Hmm.
3. Fine. Now see, you have to consider next path which do not passes through AB and DC.
Yeah.
Right?
Hmm. Because both have been blocked
Both
already.
have been blocked. Both have been consumed. You cannot
Hmm.
flow anything through that path. Now tell
Hmm.
me another augmenting path.
Yes, D,
SD,
A.
because you cannot move in this direction, so you have to move in
Yes,
that
D,
direction,
A.
A. And
C,
from A you are not able to move to B, so you have to move
C,
here.
C, and T.
Right, S, D, A, C, and T. See how easy it is, na?
Huh.
S, D, A, C, and T.
Hmm.
Okay, so S, D, S, D, A, C, T. Right, fine. So what will be the bottleneck capacity in this path? You have to consider the
Yes.
residual capacities, na? So the
Uh,
residual
3,
capacities here is
2.
2, here is 3,
2.
3, and 3. So
Bottleneck
2,
is 2.
2, very good. 2 is the bottleneck capacity. Now assign the bottleneck capacity. How to assign the bottleneck capacity? So you assign bottleneck capacity here, na? Here,
Huh.
2. Okay.
Yes, flow we should change it. So 2 and 2 will go now. 0 it
2.
becomes. This block we can.
This will also be 2.
This we can block it off this way.
This will be
This
of,
will become 1.
this will be of 2 by 3, na?
Huh.
Okay.
Residual will become 1 1 in each.
Before residual, you just add it. Otherwise, you will forget. Okay.
Adding maximum flow I've added.
Maximum flow added. Now you consider the
Hmm.
residual capacity. So this becomes 0. 2 by 2, this
Yeah.
becomes 0.
Yes.
This becomes
0,
1.
1.
This is now 1.
The
This is also
A to
now
C
1.
is also 1.
And this
Huh.
is also 1.
And
Right?
C to T. C to T will C to A to D.
A to D now.
To
D to A.
D, A,
D to
C,
A.
and T.
Now what will be the next augmenting path? If anything left,
Uh,
first you see, is there any augmenting part left?
it is one. No, it is. There is one more path.
Yes, there is one more path.
S A,
S, A,
S to A to C,
A to C,
C to B,
C to B,
and B to T also, or C to T also can be
C to
done.
T also. Anyway, you can go in any direction. So tell me,
Hmm.
S to A,
Yes, to A,
to C,
to C.
to B, you can go
Huh.
to T.
Someone joined. Lakshmi Amrita. Welcome.
Okay. So what will be the bottleneck capacity of
Augmented
this
path.
path
Hmm.
for this
B
augmenting
and
part?
T. The bottleneck will be now
2 is the
1.
residual capacity in this path, 1 is the residual capacity in this path, 1 is
1
for
1 only
this,
will
and
be
3
the
is for that.
bottleneck.
So 1 will become the
Bottleneck.
bottleneck capacity, right? So
Hmm.
assign 1, 1, assign 1, 1, assign 1, 1, and assign 1 here also. Okay. So plus 1.
This path is blocked. A to
Now
D is blocked.
calculate the
Hmm.
residual capacity for this is 1.
This
Residual
should
capacity for
be.
this becomes 0. Right? 1 by 1,
Hmm.
it is 0. Residual
This is
capacity
also
for this
0.
also becomes 0. No? Oh, sorry, we are not calculating this one. We are calculating this one. This one. C to B. We are going C to B. So this will
Mm.
1. So residual capacity is 2. And the residual capacity is what? Here 2.
Z.
2. 3 minus 1. Residual capacity from
Already
the.
we came, no? We came for that route one more time.
Which one?
B to C we have not traversed. Ah, okay.
B to C we are not traversing. C to B we are traversing. Okay. Just a minute.
Mm.
Just a minute. Okay. Now see, we are considering this is the augmenting path. Means I am doing it in this picture. Yeah. Let me copy it again.
Huh. No, you will
In exam,
rewrite
you have to
for each
draw
path.
different different figure.
Huh.
Okay. See here, we are considering this augmenting path.
Mm.
Means from this one. Okay.
Mm.
After that, this one, then this
C
one,
to B, then B to
then
D.
this one, right?
Hmm.
So if this is the augmenting part, then what will be the bottleneck capacity? What is the minimum
One.
value in this path?
One.
This is 1. This is 1,
Mm.
right? This is the minimum capacity. Okay. So 1 is your bottleneck capacity. If 1 is your
Mm.
bottleneck capacity, then assign it. So it is currently having 2. So assign
One it will be
1. It is currently having 1. So assign 1. Assign 1 to it. This is currently having 0. So assign 1
one.
to it. This is currently having 3. Assign 1 to it. Okay.
Mm.
Now when you assign 1, so you plus
Add
1 in
them.
the maximum flow. After that, you have to calculate the residual capacity. So what is the
Mm.
residual capacity here?
It will be
What will be the residual capacity here? 2 minus 1, that is 1.
one.
What will be the residual capacity of this one?
That is
1
0.
minus
That
1,
will
that
get
is 0.
blocked. Mm.
What is the residual capacity of this one? 3
It
minus
will
1,
be
that is 2. What will be the residual capacity of here? 3
again
minus
2.
1, that is 2. Right?
Mm.
So residual capacity of all the edges along this path has been calculated. Now
Mm.
see, is there any augmenting path left? Now just follow me. If you move in this direction,
Only I can go to
okay,
A.
you cannot
A.
go in this direction because
It
this
is blocked
this has residual capacity 0. You cannot move in this direction, okay,
because the sphere capacity is
because the
also there.
residual capacity of this path is 0. So
In this way
from
also.
A you cannot move anyway in any direction. Now
Same
you
thing
check
happens
this
with.
path. If you come to D, then from D you can move to A,
To
but after
A, but
reaching
from
A you
A
cannot
there
move
is no more.
anywhere. Okay.
Cannot go anywhere.
And from D you cannot move towards the C. So
We have
no
arrived at a
more
solution.
no more augmenting part left in this graph, residual graph. No
Mm.
more augmenting path is left in this graph. Okay. Hence, we
Mm.
have come to the solution. Now, what is the solution? Maximum flow is the sum of all these numbers. So, what
10.
is the value? 5 plus 2 plus 2 plus 1
10, 10.
means 10. So, 10 is the maximum flow
Mm.
along the path. Okay. So, it is the sum of all the bottleneck capacities. You can also find it from here. Sum of all the bottleneck capacities in the flow network.
Mm.
Okay. So, this is
Mm.
your maximum flow through a flow network according to Ford fulkerson method. So
Mm.
high chance of giving such a problem, and Calculation part is more always more important in this type of examination. The calculation part means this type of computation part is much more important than writing a bare code, okay, or an algo. So they will give the problems and you have to solve it. It's just like mathematics.
Yes, we did that assignment problems, no?
Yeah.
Mm.
Last day we also did the computations for unit 6 and 9, na? And
Mm.
this algorithm is the last algorithm of unit 9. Okay, fourth fulkerson method.
Single source shortest path we did.
Yeah. Now we have to move to the next unit, that is unit 11. So let's go to that part. Okay. So from here you may be asked with many short questions like what is residual graph, residual capacity, augmenting path. You may be asked with
Mm.
that. Okay, next we have what is unit 11.
11.
Unit 11. Unit 12. This is your unit 11. Okay. So unit 11 is dynamic programming. Huge important chapter in
Chapter.
algorithm. Dynamic programming. Okay. Now let me tell you something about dynamic programming. So what are the problems here? You have computing binomial coefficient, transitive closure, Warshall algorithm, and all pair shortage or Floyd algorithm. These are very fantastic algorithm. I hope you will enjoy it. Just try to remember
Yes.
because the process is not
Mm.
so hard. Okay, but if you want to grab
Mm.
it by reading the book, it will
Mm.
be a it will be a maze. Okay,
Time
so
tick.
just try to follow my words. Okay, just fast. We will computing binomial coefficient. Okay, fine. See, first of all, dynamic programming. What is dynamic programming? Okay, as we all know that uh, algorithm, there are many different types of algorithm. Means
Mm.
okay, so there are many different types of algorithm we can have,
Mm.
like greedy method. Okay, backtracking, branch and bound, and this dynamic programming, divide and conquer. So among all those types of algorithm, dynamic programming is one special type of problem solving strategy which is very
Mm-hmm.
much effective. Okay, now there is a very close relation between dynamic programming and divide and conquer approach,
Okay.
because both are having some similarities between them. Okay, dynamic
Okay.
programming and divide and conquer approach are similar, somehow similar. Okay,
Mm-hmm.
now divide and conquer approach is
Mm.
basically dividing the big problem into smaller part, as smaller as you
Mm.
can. Okay, as
Mm-hmm.
smaller as you can. So again dividing this part into two part, as smaller as you can. Okay,
Mm-hmm.
then combine these solutions, combine the solution of the sub problems. So these are sub
Mm-hmm.
problems, we can say this is the problem,
Yes.
so these are the sub
Mm.
problems. Okay, so
Okay.
combining these sub problems to find the solution, and then again combining the solutions of the sub problems to get the solution of the original problem. So
Mm.
that is the philosophy of divide and conquer
Dynamic
approach,
programming and divide and conquer.
not dynamic programming. This is the
Only the divide
concept
and
of
conquer.
divide and conquer approach. Now, why I am telling this? Because there may be a question: what is the difference between dynamic programming and
Divide and
divide
conquer.
and conquer? They are much more similar. They have some similarities between them. Now, see, in divide and conquer, these two sub problems do not overlap each other. Means you can find the solution of this sub problem without any dependency of the previous
Other one.
subproblems. The solution of the
Mm-hmm.
previous subproblems means you can you can solve a subproblem independently. In divide and conquer,
Independently.
in divide and conquer, you
Mm-hmm.
can solve the subproblem. What I said, in divide and conquer approach, you have to divide the problems into subproblems. Okay, now I am
Mm-hmm.
saying for each of that subproblem, you can solve them separately, independent from each
Mm-hmm.
other. Means it is not like that to solve the subproblem 1, you need to solve the subproblem 2. You need to subproblem 3 for the solution of subproblem 2. It's not like that in divide and conquer approach.
Mm-hmm.
Got it? Now dynamic
Got it.
programming is different from that perspective. In dynamic programming, you
Mm-hmm.
have to
I think
divide
they
the
are
problem into
dependable.
subproblem, but they are overlapping.
Mm-hmm.
Means you need the solution of the subproblems to get the solution of the bigger subproblem. Okay, so they are
Mm-hmm.
dependent. The subproblems are dependent on each other. That's why they are called overlapping subproblems. Okay, there are many more
Mm-hmm.
characteristics. I'm just taking one. Okay, now to get the solution of a subproblem from the solution of that solution is dependent on the solution of other subproblems. What we do something called memorization technique. Now what is memorization
Mm-hmm.
technique? We build a table.
And quickly.
Okay, in most of the cases we build a table. That table will store the
Okay.
solution of the earlier subproblems, and that solution will be
Mm.
used to find the solution of the next subproblems. And when we find the solution of the next subproblem, we store again, we build again a table, or we populate that earlier table
Mm.
accordingly. And again, that table will be used to solve the next subproblem. In that way, dynamic programming perform. Okay, you got it?
Mm-hmm. Got it.
Okay. So this is the philosophy of dynamic programming. Now, with that philosophy, we are going to do computing binomial coefficient. You remember the term binomial
Yes, yes.
coefficient?
In my maths, yes.
Yeah, in maths, we did it. Binomial coefficient. Not exactly binomial coefficient, we did binomial theorem. Huh.
Theorems we did.
We did binomial theorem, and in binomial theorem, we have something called terms. Okay, with that term, say x plus y whole square or whole to the power n, whole to the power n. Okay,
Mm.
so how to expand it?
It is x to the power of n
X to the power of n,
plus
x to the power of n plus
n. That c to the power of n. Some formula is there, no, like that only, no.
yeah, that is your mm, c. Here you can say like that, y to the power of n. Okay,
Huh. In between, we'll get the other.
in between we will get the terms, all terms. Okay, so
Hmm.
first term you will have x n minus 1 and y will appear, right?
Hmm.
After that you will have x n minus 2, then y square. This is for remembrance, and dot dot dot, so on, so on. Here you have the coefficient. Okay,
Hmm.
that is in terms of NCR.
Ah.
Okay, so that's why this is called. the binomial coefficient, because this is the coefficient of each term. This is the
Hmm.
coefficient of each term, okay, in the binomial theorem, binomial
Theorem.
expansion,
Hmm.
right? Okay. Now, how to calculate this one? This is the thing you have to know here. Binomial coefficient, right?
Hmm. Hmm.
See how easily we can do it. So we have to find NCR. NCR. Do you remember the term NCR?
Yes, yes. NCR, I think.
What is it? Factorial n by
By
factorial r,
n r
factorial n minus r,
n minus 1. N minus r.
right? So this is the
Hmm.
way how we compute the NCR. Huh?
Hmm.
Now here using dynamic programming, how you can compute that thing? Okay. To compute the binomial coefficient using dynamic programming, you have to use a recurrence like that. Say NCR, we can say it is like C of n comma r. Can we say that?
Hmm.
This is another way how we write NCR. Na?
Yeah.
So it is NCR is 1 when n is equal to 0, or sorry,
Hmm.
n is equal to k,
When it's equal to 1.
or k is equal to 0, or sorry, it's not k, I'm using the term r here, and r is
Yes.
equal to 0. Okay. So when n is r, n and r are equal, and r is equal, or r is equal to 0, okay, or r is equal to 0, then the value of NCR will be equal to 1. it's
1.
it's very obvious, na? Say 2C2
Hmm.
is 1, okay, 2C0 is also 1, right? It's very simple. You
Yes.
can calculate the term from here for few terms, okay.
Hmm.
Now for all other values of n and r, what will be the value of this one? This can be evaluated by this NCR. See, n minus 1 comma r minus 1 plus n minus 1 comma r,
R.
for all value of n greater than r greater than 0, means for all other values of n and r,
We
this will
have
be
defined
something
it.
like that. So this is the formula, you can say. You identify that this is a recurrence, na? What
Yes.
is a recurrence? The recursive algorithm are represented using this recurrence, na?
Hmm.
Okay. So how can we do that thing? So for that purpose, suppose you will be given, use dynamic program to compute binomial coefficient for something like that, say 7C5, something like that, or maybe even bigger than that, okay,
Hmm.
say 7C6, something like that, okay. Then how will you do that? Okay, see, we need a table. For any
Hmm.
dynamic programming, we need a table, okay. So to
Okay.
compute this thing, we
Hmm.
construct a table. How to construct a
I said
table?
yes.
Let's draw a table first.
Hmm.
So we are considering that we are going to find 7C5, okay,
C5.
7C5. So now see, I am constructing the table. mm, 7. So we will have 7 column.
Hmm.
7C5. Okay. So 1, 2, 3, 4, 5, 6, 7. Consider this one, and here also 1, 2, 3, 4, 5, 6, 7. Maybe like that. Okay. Just see. So this is the table. Using this
Okay.
table, you can easily compute 7C5 or anything up to 7C7. You can
Hmm.
compute any value up to 7C7. Okay. Now, how will you do that? Okay. Just take it. The first one, we will put in this direction all the values of n, and we will put in this direction all the values of r. Okay.
Okay.
Now put all the values starting from 0. You have to use starting from 0. So it is 0, 1, 2,
One, two,
3, 4,
three,
5. Acha,
six,
6.
seven.
We need one more. 7. 7. 7 here.
Here also the similar, 0 to 7.
Yeah. Here also you have to put 0, 1, 2, 3, 4, 5, 6, and 7. Fine.
Hmm.
Up to this is clear, na?
Ah, clear.
Okay. Now consider this recurrence relation. So for r equal to 0, what will be the value of NCR? It will be 1.
One,
So for r equal to 0 means what?
one.
R equal to 0. Which are the value of r? This one, na?
N and this
So
thing.
this
Huh.
one.
The first
So the
column.
first
Hmm.
column, first column,
Hmm.
first column will all be filled with 1. Right? You got it?
Hmm.
Because we
Hmm.
put when r is equal to 0, then NCR value will be 1. So the
Hmm.
r value is 0 here. This is the value of
Hmm.
r. These are the value of
Okay.
r. Okay.
Hmm.
So when the value of r is 0, so all the value, these cells give you the value of NCR. Okay.
Hmm.
So all the values in this column will be filled with 1.
Will become one. Hmm.
Now there is one more condition. When n is equal
N.
to r, then also the value will be 1.
Hmm.
So which cells here represents n is equal to r?
That is vertical, horizontal.
No, the
N is horizontal.
diagonals. The diagonals, na? Say 0,
Okay.
0. This is 1.
Mm-hmm.
1 and 1. This will also be 1, na? This
Ah,
2
okay.
and 2. This will be 1. 3 and 3. 0, 1, 2, 3. This will be 1, right?
Hmm.
4 and 4. 0, 1, 2, 3, 4. The diagonal. Because this is a
Hmm.
square matrix.
Hmm.
So 5. So 0, 1, 2, 3, 4, 5 will be 1. 6. This will be 1. 7. This
Last
will
year,
be 1.
second one and last one. Hmm.
Why we are doing this? Because to populate the cells according to these two conditions, when n is equal to r And when r is equal to 0, all elements will be filled with 1. So we did it.
Will fill
Okay.
with.
And we have to calculate about for the rest of the cells. Okay. Now, which cells we need to construct? We do not need to construct these cells at all. These cells. Why?
Because it cannot be, it is for all greater than 0.
See, if you want to construct the item for this, then what will be it is? It will be 1C2. If you want to construct the item for this, then what will be it is? So it will be 2C5.
C5.
Are you understanding this thing? This
Yes,
is
yes, I'm getting it.
combination.
Yes,
What
yes.
is the meaning of combination? That means from two items
Uh,
you are taking, out
hmm,
of two items you are taking five items. Is it possible?
5 items. No, it's not
It's
possible.
not possible. That's why these elements will need not to be calculated.
Discarded.
We only
Okay.
have to calculate these amount of cells. Okay. So
Okay.
among these cells, we need what? 7C5. So what will be our 7C5? 7. This is your 7. Means
Hmm.
that what is the n value? 7 is the n value. What is the r
Hmm.
value? 5 is the r value. So which one is your n represent? This is your n. This is
Hmm.
your n, na?
Yes.
This column is n, means
Yes.
these rows. So
Hmm.
this is your 7, and which one is your 5? So this one is
5
your
will
5.
be. Hmm.
This one.
Hmm.
So the cross section means you need the item in this cell.
Yes.
They have asked you to get the value of this cell.
Hmm.
Tell me, up to this is okay?
Yes.
Okay, fine. Now we will find something amazing. It's very simple.
Hmm. Hmm.
You have to populate this thing. Okay. How to populate this thing? You just go at the above line, above row. Okay.
1, 2, 3. Yeah?
Above row. Okay.
Okay.
You just add these two
Oh, oh.
element and put it over there. I'm just first showing you the
First.
concept. Okay. After that, I
Hmm.
will show you the formula.
Hmm.
So now tell me to compute the element for this cell, what I will do.
You should go to the above element 2 plus 1, 3.
So this I have to add 3 here for this.
Again, I should go up there, then 1 plus 2 plus 1, I think.
No, no, no. Only the two element you have to sum.
Okay, 1,
The
2, and 1,
consecutive
3.
elements need to be sum.
Okay, 3 again.
So it will be 3. Simple. Na?
Hmm.
So now tell me what will be the value of this item. Go upward direction one step. Then
3 plus 1, 4.
4 here,
Again, it will be going up 3 plus 3, 6.
6 for this,
Again, it is 4.
plus 1 4.
Okay, here it is 5.
Here it is 5,
Then 10.
10,
Again 10.
10,
Again 5.
5,
6.
6,
15.
15,
20.
20.
15.
This is 20, na? This is
20,
15,
15, 6. 6.
6. This
Here
one,
it is 7.
7,
It is 21.
21,
35.
35,
Again 35.
35,
21.
21,
7.
7. So we got the value here 21.
21 is the value.
21. Now let's check. So we were calculating 7C,
C 5.
7C5. So 7C5 means factorial 7
By.
by factorial 5 and factorial 7 minus 5, na?
Huh.
7 minus 5. So let's compute factorial 7 means 7 into 6 into factorial 5.
126 into
We
5
can write.
factorial is 120, 6 factorial 7.
No, we do not need to calculate factorial 5 because this factorial 5 and this factorial 5 will be cancelled out.
Hmm.
This factorial 5 into
Oh, we can
factorial
simplify.
2.
Hmm.
Factorial 2. So this factorial 5 will be cancelled out. So
Hmm.
factorial 2 means what? 2. So this will be your 42 by 2, and that is 21. This is the result. Okay,
Hmm.
you got it.
Yes. So
So
this is
this
the
is the way how
42.
you have to compute this table. See here, see the
Okay.
dynamic approach here. While you are computing the value for this item, you are using the values of the previous subproblems, the previous row. Are you getting?
Hello.
Hello, hello, hello. So you understand
Yes, yes,
the
I got it.
computation part of this, how to compute this NCR binomial
Yes, yes.
coefficient.
Binomial. Yes, I got it.
Okay. Now last you see, I have shown you methodically how to compute the items for each element, na? Each cell. Hello, hello.
तो चलेगा शायद अभी जो भी एक्टिव कनेक्टेड इन डिवाइसेस थे वो डिस्कनेक्ट करके आ गई मैं
Okay. So this is the way how you have to compute the binomial coefficient. Now see just one more thing. See here, when I am
हम्म
when I am calculating the value for this item. Okay,
हम्म
I am using the values for the previous row. Na?
previous one yes it
See
is
here.
overlapping
See here.
हम्म
Here. So what we are doing? What we are doing here? We are
depending on
making a sum of these two figures. Na?
हम्म
See here. C of n minus 1 means the previous
हम्म
row,
हम्म
and r
and r
minus 1
minus one
means the previous
previous
column
column
also. That means to
हम्म
calculate this value, you have to consider this one.
correct
And C of n minus 1 means the previous row but the same column, right?
हम्म
So previous row but the same column means this. So these two you need to sum to produce the value here. Okay, you understand now this recurrence? This
yes
recurrence?
yes
Okay.
yes
So this is the way how you have to compute the binomial coefficient. Okay, means the
हम्म
NCR value. Simple. Okay.
okay
And also chances of coming binomial coefficient is very good
for 5 marker
for 5 marks question.
हम्म
Okay. So coming to next one quickly. So what is the next one? Computing binomial coefficient was there, and the transitive closure. What shall algorithm? Okay.
transit closure
Transitive closure. What shall algorithm?
mm. any one thing will in CA3 that Warshall was there no
What shall algorithm? Ha, few questions were there from what shall algorithm.
mm.
What shall
आपका आवाज
algorithm and what shall for Floyd algorithm are two different algorithms. Okay. What shall
आपका
algorithm?
आवाज थोड़ा ब्रेक हो रहा है मेरा नेटवर्क का प्रॉब्लम है कि कुछ अदर प्रॉब्लम है पता नहीं चल रहा है
आप एक काम करो, आप एक बार डिस्कनेक्ट करके फिर से रिकनेक्ट हो जाओ.